All right, guys, so this video is going to go over how to find trig values of any angle, really any angle in what we'll later on call the unit circle, or any angle where the reference angle is 30, 45, or 60 in the coordinate plane. So I'm just going to start off with a quick review of reference angles. I'm going to do B and C here for our reference angles. I lost my drawing up here. So for negative 310, remember all of our angles start on the x-axis. That's our initial side for standard position. So if we're drawing an angle that's negative 310 degrees, get my screen back to normal, then we're going down in the negative direction and all the way up. This would be negative 180. We get up here to negative 270, and it's not quite a full circle. Negative 310, we'll say somewhere back here in quadrant 1. Pressing all kinds of buttons here. So that would be our negative 310. For 13 pi over 8, a couple ways you could do this. You can change it to degrees, which remember, if you're trying to change radians to degrees, we would multiply by 180 divided by pi, find your degrees. But I'm going to leave it in radians and think about where it would be. So we know pi is over here for radians, and 13 pi over 8, well, if I get a common denominator with pi, that would be like multiplying by 8 over 8. So this would be 8 pi over 8, and 13 pi over 8 is more than that. So if I went all the way around my circle, that would be 2 pi. So let's do the same thing. Let's get a denominator 8 to compare. So I'm going to multiply by 8 over 8, and that gives me 16 pi over 8. So I just have to think, is 13 pi over 8, and I'm going to write it up here, is 13 pi over 8 closer to 8 pi over 8 or 16 pi over 8? Hopefully the answer that we're thinking is it's closer to 16. So that means I'm going to go into the fourth quadrant. Doesn't matter where, as long as you're in the right quadrant. We're over here. And there's actually only 3 pi over 8 left, so that'll be our reference angle. So I've drawn both of these angles. So to find the reference angle, we want to know how much is left over to get to the x-axis. So for negative 310, to make it to negative 360, that would be 50 degrees. So our reference angle is going to be 50 degrees there. Similar idea over here, 13 pi over 8. Well, how much more do we need to get to 16 pi over 8? We need 3 more in the numerator, so that's 3 pi over 8 more. So that would be our reference angle for that second one. So you guys can try out that first one. Remember, trying to figure out how much of the angle is left between your angle and the x-axis. All right, so I'm going to go through this method, and then I'll kind of end this video and do another one for a couple examples here. But to find the value or trig function, sine, cosine, tangent of any angle, we have a couple steps we're going to go through, and I call this decs or des, however you want to remember it, D-E-C-S. So the first thing I like to do, similar to what we did up top, is actually draw your angle, or in this case, our triangle. So we're going to do this example, evaluate tangent of negative 240. So first I'm just going to draw where negative 240 is in the coordinate plane. So negative, right, we're going around, this would be negative 90, negative 180. This would be negative 270 here, so we're in this quadrant here. So that's the first thing. Draw my triangle, and we're going to see how we make this a triangle. And actually, I shouldn't put my check mark yet. We need to find the reference angle. So this is how we're going to create our triangle. Once we've drawn our angle, we're going to drop down to the x-axis. We're always going to the x-axis. We don't want to go to the y. We're going to the x-axis. That will create a triangle for us. So now this guy in here is our reference angle. So we want to think about, for the reference angle, how many degrees is between our angle -240 and the x-axis, which over here would be -180. So if we want to use our calculator to help us out, or from 180 to 240, that is 60 degrees. So now, step one's our biggest step. We drew our triangle and found our reference angle. All right, once you're there, we evaluate the trig function. So we're trying to do tangent, which is the OA in SOHCAHTOA. So we need the opposite over the adjacent. Now without a calculator, we will only have 30, 60, 90 reference angles, or 45, 45, 90 reference angles. So you need to remember these special triangles that we've hopefully been hammering in. So in a 30, 60, 90, this is usually x, across from the right angle is 2x, across from 60 is x root 3. Now, if they don't give us any lengths to make our lives easier, we just say, well, let's say x is 1. That'll make 2x equal to 2, and this guy equal to root 3. So I'm going to use these values instead of variables to make this guy a little more manageable. So I'm going to 60. I go opposite side. Opposite 60 is root 3. And I need my adjacent side. So here's 60. Adjacent side is a 1. I'm going to erase some of this stuff to clean up a little bit. All right, so we found the trig function. So tan of 60, and we're really finding this, so I'm going to write this, equals opposite root 3 over 1. Now, the last thing we have to do is check the sign. And I actually like to do this when I'm writing the sides of my triangle. So this is why it's different from just a regular 30, 60, 90. If we're in the coordinate plane, this is the xy axis. I went to the left. So this 1 down here needs to be negative, right? If I'm graphing points over here, this is in a negative quadrant. So this to the left is negative. When I go up, that's positive. So here we're fine. I need a negative for my answer. So my answer will be negative root 3 over 1. Since the denominator is 1, I don't really need it. Negative root 3. All right, so to remember, I'm going to just go over this quickly and then end this video and finish some practice. But to remember kind of quickly the signs, right? If you'd rather not draw a triangle, then we use this little mnemonic device, they call it. Since quadrant 1, here, all of the trig functions are positive. So I'm going to write over here, all, nice big capital A. In quadrant 2, only sine and its reciprocal cosecant is positive. So I'm going to write over here, sine, the big S, is positive. It's the only one with the reciprocal cosecant. Quadrant 3, only tangent and cotangent are positive. And quadrant 4, only cosine and its reciprocal secant are positive. So there's a lot of devices, mnemonic devices out here to remember this. But to remember it, A, S, T, C, one way to remember it is add for A, sugar for S, 2 for T, coffee for C. So add sugar to coffee. This will tell you what is positive in which quadrant. So quadrant 1, all are positive. Quadrant 2, sugar, add sugar, sine is positive. Quadrant 3, 2, tangent is positive. Quadrant 4, coffee, cosine is positive. So I'm going to end this video because I think we're getting pretty long. I'll do some more examples of these in my next video, and you guys can try them out.